hydrates. If you remember back with nomenclature, hydrates were ionic compounds that have water trapped in them. So I'm going to give you two new terms, hydrated salt and anhydrous salt. First of all, they're the same salts. The difference is, think of hydrated, think of you always on a hot day, they say keep hydrated, means keep plenty of water in you. Anhydrous also means without water or dehydrated. So again, as you can see on the right hand side in parentheses, barium iodide is the same salt. The hydrated has two waters in it. The anhydrous has no water. It's dehydrated. So what we want here over in this overall process when we deal with this, we're going to go after, in this situation, we're going to go after how many waters. Was it a monohydrate, a dihydrate, a trihydrate, a tetrahydrate? We're going after that number, which represents moles. So my barium iodide up top has 2 moles of water. We're going after that number 2. How can we calculate what that number is? So the problem is we need both the salt and the water as individuals. In the hydrated form, the problem is the salt is physically trapped or the water, is physically trapped within the salt. So we're going to separate them out, and we're going to get the mass of the water and the anhydrous salt. We're going to then convert them both to moles, and then we're going to take the larger number divided by the smaller number, which is going to end up being moles of water to moles divided by moles of anhydrous salt, and that's going to give us a whole number. Is it 1 for mono, 2 for di, 3 for trihydrate, 4 for tetrahydrate, and so forth. So we have this example. We start out on the left hand side, we have our salt that's hydrated, and then we put it at the flame, all the water evaporates out, and the salt on the other side is anhydrous. So the water is evaporated all the way, and it is now dehydrated. So on the left hand side, water and salt combined. On the right hand side, just salt alone. And the water we lost, we don't know exactly how much water we lost, but we're going to figure that out. So in this situation, we have barium iodide hydrate is heated in a crucible. Crucible is just a clay container. We're going to determine the formula of the hydrate given the following data. So before heating the salt, it weighed in at 10.07 grams of barium iodide. Now that had water in it. It was hydrated. We heated it, and all the water evaporated. All we had left now was the salt, and it weighed in at 9.520. So we recognize right away that, you know what, the difference between the initial mass and the final mass was only the difference of that of water. Just simply subtract them out, add the mass of my water. So now I'm going to continue on. I need both. Now I have the salt and water as individuals. So my barium iodide and my water now have to get from mass to moles. So I'm going to do that using molar mass. So I'm going to calculate. I take my mass of water, and I know the water weighs in at 18.02 grams for every 1 mole. I put moles over grams, one reason only, my grams cancel out, and I get my water to moles. I'm going to do the same thing for barium iodide. I have 9.520 grams, but I have to get its molar mass, so I'm going to go to the periodic table and add up 1 barium plus 2 iodines, and it weighs in at 391.13 grams per mole. Moles over grams, one reason only, grams cancel out. So my moles of barium, I have my moles, my barium iodide, my salt. So now I'm going to take the larger divided by the smaller, same process we did before with the empirical formula, but it ends up being the water divided by the salt. And so it's going to give me a multiple, and I use regular rounding rules, but this comes out to be 2. And so now what I'm going to do is I realize it is a di. 2 tells me it's just a dihydrate. Barium iodide, 2 means 2 waters. Another example. I have zinc sulfate, has water in it. I heat it up, all the water evaporates out, and for my zinc sulfite, I have remaining now the anhydrous salt. So the difference between the two is the mass of my water. The difference between the two. So I realize my mass, my water weighed at 2.60 grams. So a combination of my salt plus my water ended up adding up to 5.20 grams of zinc sulfate, something hydrate. So I have the mass of the salt and the mass of water. I now need to get them from mass to moles using molar mass. So this is the same process now as the empirical formula. Get from mass to moles using molar mass. A little more work because we're dealing with compounds, not individual elements. So my water weighs in 18.02 grams. My grams cancel out, end up in moles of water. I now have to add up zinc sulfite. So I have zinc plus 1 sulfur plus 3 oxygens weighs in at 145.43 grams. Moles over grams. My grams cancel out. I get the moles of my zinc sulfite. And then I'm going to take the larger number divided by the smaller number, or divided through by the smallest answer, and I get the number 8. So it is an octahydrate, 8 waters. So zinc sulfite, 8 waters.